Hello, good, hello everyone. This is Ankit Tripathi, DPS Sitapur. Today I will teach you motion, new chapter, motion and its description. In these chapters, we will discuss how many types of motions, its applications, definition of speed, accelerations, uniform accelerations, retardations, etc. Today we talk about the its motion. What is the motions? One questions from in this chapters very important. What is the motions? Motions, I can define it. Motion means a motion, a body is said to be in motion. Its position changes continuously with respect to a stationary object taken as a reference point. This is called the motions. As you seen in the figures, when the position of a car changes continuously with respect to a stationary object like houses and tree, etc. So we say that the car is in motions. In this figure, car is in motions, etc. Next topic, distance traveled and displacement. Distance traveled and displacement. Distance is a scalar quantity. Distance traveled by the object for the largest distance. In other words, in spite of displacement measured by the shortest distance between the two objects is called the displacement. So we can say that distance is a scalar quantity and displacement is a vector quantity. Distance that traveled by a body is the actual length of the path covered by a moving body irrespective of the direction in which the body travels. Is called distance. Distance is a scalar quantity. Its unit of distance is meter. In other words, displacement we can define it. Displacement means when a body moves from one point to another, the distance traveled refers to the actual length of the indirect path, whereas displacement refers to the straight line path between the initial and final positions. As seen in the figure, displacements suppose that any object starting from the rest position and come back in the same position. So in this figure, displacement will be 0. So we can say that displacement traveled by the shortest distance between the two objects is called the displacement. Displacement is a vector quantity. It is unit of displacement is meter. So we talk about the how many types of physical quantity. Physical quantity, there are two types: scalar quantity and vector quantity. Scalar quantity and vector quantity. So what is the scalar? Scalar means such type of a quantity so only magnitude is present. It is called the scalar quantity. Vector quantity. In the vector quantity, we can define it such type of a quantity, magnitude and directions both will be given. It is called vector quantity. Example of scalar quantities: length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work and power, etc. Such type of example is called scalar quantity. In other words, vector quantity example will be displacement, velocity, accelerations, momentum, force, lift, drag, thrust, weight. All the examples belong to vector quantity. This is in scalar, volume represented scalar quantity and velocity represented vector quantity, because those vector quantity which is represented by arrow, a head represented to the direction of the velocity. So such type of a quantity is called vector quantity. In other words, distance is a scalar quantity. Why? Because it has magnitude only, it has no specified directions. Distance having no directions. So in spite of displacement, we talk about displacement is a vector quantity because it is denoted by vector, so its direction will be its magnitude as well as the directions. Third points, we talk about distance traveled by a moving body cannot be zero, because but the final displacement of a moving body can be zero. So displacement of a moving body will be zero. Displacement will possible, but the distance traveled by a moving body cannot be zero, because final displacement of a moving body can be zero. If the displacement of a moving body will be zero, why? Because after traveling a certain distance, the moving body finally comes back to its starting positions, to its starting position of the points. So such type of examples is called the distance, scalar and vectors. Next point, what do you understand by uniform motion? Uniform motion, what do you understand by uniform? According to figures, it is clear that uniform motion, they are represented graph and vehicles. The vehicles moving on a road in straight direction, same time, same equal time at intervals. So the in the graph represented displacement and time. On the y-axis, I will consider displacement will be 10 meter to 60 meter. In spite of, on the x-axis, we will consider the value of time on the x-axis 1 meter to 6 meter. So we can define the uniform motion. Uniform motions, a body has a uniform motion if it travels equal distances in equal intervals of time. I repeat again, uniform motion means a body has a uniform motion if it travels equal distances in equal intervals of time. Why? Because no matter how small these time intervals may be, so the distance time graph, the graph represented, this type of a graph is called distance time graph. The distance time graph for uniform motion is a straight line. For example, in this figure seen the motion of a car in a straight line with a constant speed. This is such type of example is called uniform motion because car is travels equal distances in equal intervals of time. This is the best example of uniform motion. And we talk about next non-uniform motion. Non-uniform motion means such type of a motions non-uniform. It means in curved form. Non-uniform motions will be in curved like as the a body has a non-uniform motion if it travels unequal distances in equal intervals of time. So the distance time graph for a having non-uniform motion is a curved line. तो इस टाइप के जो ग्राफ हैं क्या रिप्रेजेंट कर रहे हैं? इट इज़ रिप्रेजेंटेड नॉन यूनिफॉर्म मोशन बिकॉज दिस टाइप ऑफ a not a straight line. This is a curved form. So such type of example is called non-uniform motions. Another, we talk about what is the speed, velocity and accelerations. Speed, velocity and acceleration, all the physical quantity, it is represented that speed, velocity and acceleration is known as the vector quantity. Velocity is a vector quantity, acceleration is a vector quantity, speed is a scalar quantity. Why? Because we talk about first speed. Speed means any object having the speed like as a car, vehicles, etc. It is defined as speed. Speed means speed of a body gives us an idea of how slow the fast that body is moving. Speed of a body is equal to distance traveled upon time taken. So we can write in mathematical form v is equal to s upon t, where v equal speed and s is equal distance traveled. Taken unit of speed is meter per second. We always remember that unit of speed will be meter per second because speed it is denoted by v and displacement measured in meter and time measurement second. So unit will be meter per second. In this graph you can see that time on the y-axis and x-axis usual measurement the displacement. So this type of a graph represented time displacement graph. Secondary, uniform speed. What is the uniform speed? What do you understand by uniform speed? Uniform speed means a body has uniform speed if it travels equal distance in equal intervals of time, no matters how small these time intervals may be. Such type of speed is called uniform speed. Unit will be same like as the speed, uniform speed, instantaneous speed, all the unit will be same. It is called meter per second. So we talk about next average speed. What is the average speed? Average speed you can see in the figure. Average speed means the average speed of a body is the total distance traveled divided by the total time taken to cover this distance. So Average speed equal total distance upon total time taken. It is called average speed. Average speed denoted by V bar. Its unit will be meter per second. In this graph, the distance, displacement and time, the graph represented to the non-uniform. So we talk about the next step, velocity. Velocity is the very important parameters of the physical quantity. It means this is such type of a quantity is called the velocity. Velocity is a vector quantity because velocity of a body is the distance traveled by it per unit time in a given direction. So velocity is equal to displacement upon time taken, where the symbol has their usual meaning. V is called velocity of the body and S is called displacement of the body and T is equal to time taken. So the SI unit of velocity is the same as that meter per second, in other words meter second inverse. So we can use the bigger unit of velocity will be kilometer per hour. The smaller unit, in other words SI unit of system, that is velocity meter per second, and bigger unit of velocity kilometer per hour. So uniform velocity, we talk about the next point, uniform velocity. Uniform velocity means a body has a uniform velocity if it travels in a specified direction in a straight line and moves over equal distances in equal intervals of time, no matter how small these intervals may be. So this type of a graph represented to displacement time graph. In this diagram, the velocity of a body can be changed in two ways. How many ways? The two ways represented, first point by changing this speed of the body and by keeping the speed constant but changing the directions. So speed and velocity are not always equal in magnitude. We remember important points, speed and velocity are not always equal in magnitude because speed is a scalar quantity and velocity is a vector quantity. So never always equal in magnitude. In spite of the magnitude of speed and velocity of a moving body is equal only if the body moves in a single straight line. If however a body does not move in a single straight line, so then the speed and velocity of the body are not equals. The average speed of a moving body can never be zero, but the average velocity of a body can be zero. According to conclusions has come, the average velocity of a body can be zero. In this figure, the speedometer shown in the figure, in this speedometer accelerations will be 0 meter per second square and velocity will be 0 meter per second. So such type of a quantity is called speed and velocity are not always equal in magnitude. We talk about next point, accelerations. Accelerations we can define it. Accelerations of a body is defined as the rate of change of its velocity with time. Acceleration equal to change in velocity upon time taken for change. So we can write in mathematical form, acceleration means change in velocity means final velocity minus initial velocity upon time taken. A is equal to v minus u upon t, where a is called acceleration of the body and v is equal to final velocity of the body, u is called initial velocity of the body, and t is equal to time taken for the change in velocity. So the SI unit of acceleration is meter per second square. Acceleration is a vector quantity, and when a body is moving with uniform velocity, its accelerations will be zero. In this figure, the plotting the graph between velocity and time. Velocity and time graph represented three types of accelerations which represented in the diagram. Positive accelerations, it originate from 0 to 4. Positive accelerations and zero accelerations, last will be negative accelerations. So zero accelerations means the body at the rest positions, means this is called zero acceleration. Negative accelerations, it is also known as the retardation. So this is called the accelerations. We talk about difference between now uniform acceleration and non-uniform accelerations. Uniform and non-uniform accelerations, that is, uniform acceleration means the velocity increases by equal amounts in equal intervals of time. The velocity time graph of a body having uniformly accelerated motion is a straight line. Such type of a graph is called uniform accelerations. The plotting the graph between velocity and time, it is represented, you will get a straight line. So such type of a graph, it is called uniform accelerations. In spite of non-uniform accelerations, non-uniform accelerations means velocity increases by unequal amount in equal intervals of time. This is called non-uniform motions accelerations. So the velocity time graph for a body having the uniform non-uniform accelerations is a curved line. The curved line represented to non-uniform accelerations. So there are two graphs represented to uniform and non-uniform accelerations. We talk about next point, retardations. Retardation, just I have discussed. Retardation means deceleration or negative acceleration. Negative acceleration means if the velocity of a body increases, the acceleration is positive, and if the velocity of the body decreases, so the acceleration is negative. In this figure, the graph between velocity and time, it is represented to the retardations, because retardation is measured in the same way as accelerations. So retardation is actually acceleration with the negative sign. The negative sign indicate to the retardation. The graph represented to the retardation curve. In other words, negative accelerations, because velocity measured in meter per second on y-axis and time measurement in the second on the x-axis. AB represented the curve joining the 4 to 14. This is represented to the negative accelerations or retardations. So we come next point, average velocity. Average velocity. Average velocity, what do you understand by average velocity? Means average velocity equal to initial velocity plus final velocity. V bar equal to u plus v upon 2, when a bar on the v denotes the average velocity and u is the initial velocity and v is the final velocity. So this graph represented to three lines represented in graph. The green line shows the fast steady speed moving from 0 to 100 meter in 5 seconds. In spite of blue line shows the journey with a stop and a return to the starting positions. The red line shows that journey starting from 2 seconds later than the other two with an initial accelerations, the deceleration and then a stop. So some questions state the type of motions represented by given graph. Store is uniform motion. Second question represented the direction of velocity changes, means circular path with a constant speed. This is called accelerated motion. Third questions, under what conditions magnitude of average velocity. This is the move of an object in a straight line. So as you simple questions, a farmer moves along the boundary of a square field of a site 10 centimeter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So according to questions, by using the Pythagoras theorem, hypotenuse square go to perpendicular square plus base square, so you will get the result 14.414 meters. It is represented to the after 2 minutes 20 second displacement is equal to the 14.14 north east from the positions. Graphical representation of motions. As you know, motion equations there are three types. First motion equation, distance time graph. The slope of a distance time graph indicates speed. If the distance time graph a body is straight line, then its speed is uniform motion. So the third point, if the distance time graph of a body is curved line, then speed is non-uniform motion. So speed time graph, it is also known as the velocity or time graph. There are three types. Speed equal to this time graph when the speed remains constant. This type of a graph represented to the speed time graph. Third, a straight line sloping upward shows uniform accelerations. Accelerations means change on speed upon time taken. According to questions, that is, you will get the result the speed time graph when the initial speed of the body is not zero. This is shown in the figure. This is known as the uniform retardations. In the other figure, distance traveled by the body in case is equal to the area of trapezium equal to the OB plus OC into OA upon 2. It is equal to the uniform acceleration, in other words trapezium. Now try these graph, distance time accelerations, uniform accelerations, etc. So questions you will solve, you will calculate these accelerations in these questions. First question, acceleration formula will be used v minus u upon t. Applying using this value, you will get minus 1.112 meter per second square. Second questions, find how far the train will go before it to rest. So in this question value given, final velocity will be 0 and acceleration will be minus 0.5. So using third motion equations, v square equal to u square plus 2as. Using this value, you will get s is equal to 625 meter, where s is called the distance covered by the train. So third derivation, the motion equation by graphical method. In this figure, first equation represented to the v is equal to u plus at. This the graph represented to the a is equal to db upon d. In other words, acceleration is equal to db upon ab. Equation first, second and third you will get putting the value from equation, these equations. V is equal to u plus at. This is the first motion equations. So we can use the s is equal to ut plus half at square. Ut plus half at square means, according to figure, distance travelled equal to area of the figure OADC equal area of the rectangle OABC plus area of the triangle ADB. We will now find out area of the rectangle OABC and the area of the triangle ADB. So you will get area of the rectangle OABC equal to OA into OC equal U into T equal to UT. Second, area of the triangle ADB equal half AB into DB. So you will get 1 by 2 T into AT. You will get multiply 1 by 2 AT square. So distance travelled equal to S is equal to UT plus a half AT square. Third motion equations we can derive V square equal to U square plus 2AS. So in this equation the distance travelled S by body in time T is given by the area of the figure OADC, which is trapezium. Distance travelled equal to area of the trapezium OADC, which are equal to sum of parallel side into height by 2. So S is equal to OA plus CD into OC by 2. So now OA plus CD equal to U plus V according to figure, and OC is equal to T. Putting the value in these above relations, we get S is equal to U plus V into T by 2. We know that T is equal to V minus U upon A from equation first. Putting the value of T in equation first, S is equal to U plus V into V minus U upon 2A. 2A is equal to V square minus U square. In other words, V square equal to U square plus 2AS. This is the third motion equations. Summary: in all chapters, summary will find out that is motion. A body is said to be in motion if its position changes continuously with respect to a stationary object. Second, distance. Distance is a scalar quantity. Path length and displacement means shortest path means vector. Uniform motion. A body has a uniform motion if it travels equal distances in equal intervals of time. So non-uniform motion, a body has non-uniform motion if it travels an equal distance in equal intervals of time. So speed is equal to distance upon time. Its unit will be meter per second. Uniform speed means equal distances in equal intervals of time. Average speed means total distance upon total time. So in velocity, now next point, velocity means velocity of the body is the distance traveled by it per unit time in a given direction. The velocity is equal to displacement upon time taken. V is equal to S upon T. Unit is meter per second. Uniform velocity. A body has a uniform velocity if it travels specified directions in a straight line, moves over equal distances in equal intervals of time. Summary: speed and velocity are not always equal in magnitude. The SI unit of acceleration meter per second, and formula will be equal to V minus U upon T. Uniform acceleration means the velocity increases by equal amounts in equal intervals of time. Non-uniform acceleration means the velocity increases by unequal amounts in equal intervals of time. If the velocity of the body increases, the acceleration is positive, and if the velocity of the body decreases, the acceleration is negative. And the area under the speed time graph gives the distance traveled by the body. So the three type of motion equations: V equal to U plus AT, S equal to UT plus half AT square, V square equal to U square plus 2AS, where the symbol has their usual meaning. V is called final velocity, U is called initial velocity, A is called linear acceleration, T is the time, and S is the displacement, and U is called the initial velocity of the object. Thank you, sir.